All right, so this video is going to be sort of an introduction to geometric proofs. If you have not watched the video from class on Intro to Algebraic Proofs, then you might want to watch that first, because this is really just a way to get you thinking about how a geometric proof, even though we're going to use properties that we don't necessarily know completely yet, or we might not have memorized, how it's very similar to what you're going to see in an algebraic proof. So let's talk a little bit about the idea of what a proof looks like for us in this class. It's going to continue to be in this two-column format. There are other ways to write proofs. You can write paragraph proofs. You can write indirect proofs. You can do flow proofs. But for us, we're generally going to stick with two-column proof, just because I think it's sort of, at this point especially, the easiest thing to do. The first column is still your statement column. And by statement column, I mean it's you stating what you think is happening, what should happen, what the next step should be. If you think about it in terms of an argument, right? Say I was here to argue for or against the death penalty. My first statement would be, I am going to argue, against the death penalty. Then I would have my next statement, and then finally why I think that should finally happen. But I'm backing up each of my statements then with the second column, which is the reason, right? So I might initially say, today in my speech, I'm going to tell you why I am against the death penalty, and then here is the initial reason. Then I'll give you sort of the next statement as to why I'd be against the death penalty, and then its reason. It's not as loose as that in math, because in math, you are limited to a lot more in terms of properties and theorems, but it's that kind of a concept. Is the statement is going to be what you're saying, and the reason is why you say it. You will generally have at the top, of course, the given statement and the prove statement. And then my favorite thing about proofs, especially if you're first learning them, and this is regardless of the style of proof that you're doing, the first statement is always going to be what's in your given, and your first reason is always going to be given. Your last statement, right, so say this had 4 steps to it, your last statement will always be whatever the proof was. So let me do a quick algebraic one just to kind of give you the idea of it, so that if you haven't thought of one recently, you can be like, oh yeah, okay, I get what you're saying there, Miss Id. So say I have something like 3x plus 2 equals 4x minus 8. I'm trying to get that solved, and what's nice about an algebraic proof anyway is they'll give you the answer. So this might say x equals 10. Okay. So your first statement is always just a repeat of the given statement. And then why is that happening? It's because someone gave it to you and wanted you to prove it. All right. So your first statement is the actual what they're saying in the given. The first reason is given. Then you go ahead and you start doing your mathematical processes. So if you haven't solved in a while, this might be a little weird, but what you want to think about is, how do I start to solve this? I might do something like subtract the 3x to the other side to collect my x's. Once I do that, I'm left with 2 equals x minus 8. And that was by subtraction. How did I get from the first step to the second step? You won't usually see the in-between. You'll just see the result. And you have to realize, how did I change from here to here? Oh, I subtracted that 3x. Hence my reason is subtraction. All right, next step, I'm going to go ahead, I'm going to add the 8 to the other side. That's through addition. And then, interestingly enough, even though we've finished solving the problem, the proof asked us to say it in the format x equals 10. This is the most geometric you're going to see in this particular proof. I want to switch the order that this is in by flipping the x and the 10. That is a property that I talked about in class on Thursday called the symmetric property. The symmetric property says if the right hand and the left hand side are equal, you're allowed to flip them and they maintain their equality. So given is always the first step. The statement from the given is always the first step. The statement from the prove is always the last step. And then generally you have to figure out what steps will get you from here to here and how you're going to then continue those steps. Now, there are a couple of things in geometry, and I'm going to do just probably one geometric proof here. And this is going to be using some stuff that you might not have seen yet, But like I said, this is really just an intro, and we're going to get more in depth with this when we're live together in a class. And if you're just randomly watching this and you're not live in a class with me, then, you know, I guess you could always ask me to make another video. All right. Now, the difference between an algebraic and a geometric proof is there isn't much difference. The biggest difference to me is that a geometric proof almost always is going to have a picture related to it, or it's going to ask you to draw a picture. Because so much of what you're going to get from a proof is going to be based upon what you see. That's why so many students, I think, do better in a geometry class initially than they do in an algebra class, is because geometry is a lot what you see and identifying things in a picture, and it's very visual. Whereas algebra is a lot more rule-based, and you don't necessarily look at it and see something you could try. So for this one, I'm going to say angle 1 and angle 2 are vertical. And then what I want to prove is I want to prove that angle 1 is congruent to angle 2. This is going to take me a little bit, and in fact, I might go ahead and I might change this to the measure of angle 1 being equal to the measure of angle 2. And we'll talk about why that's different. And then there's going to be a picture. All right. Vertical angles are angles that are opposite each other when you cross lines. They sort of look like opposite V's, sort of like that. These two are vertical, and what we'll eventually see is that vertical angles are congruent. I'm sticking with measure right now, though, because that way we have to do a little less work. And then I'm going to go ahead and in the picture, I'm going to call that angle 3. Now, even if you got a proof like this and you had absolutely no idea what to do with it, you could always get the first statement correct and the first reason, and eventually if it was numbered, you could get the last statement. So our first statement is angle 1 and angle 2 are vertical. I tend to shorthand in my first statement because we already have it written somewhere. So if someone is reading my proof for the first time, especially in a high school class, if they can't understand what my shorthand is, they can just go right back to the beginning of the problem. How do I know angle 1 and angle 2 are vertical? Somebody gave it to me. I don't know why it's important to them. I don't really care why it's important to them. If they give it to me and they ask me to do something with it, then they gave it to me and I'm going to try to do what I need to do. All right. Now, depending on who you are as a person, who you have as a teacher, it can depend on how formulaic and how formal you need to be. Some teachers will require you to go through multiple steps to say certain things. Some teachers will only require you to go through one step. I'm going to do this in more the shorthand version. So if you are a person that is a geometry purist, I apologize. But this is, we're working on just some nice basic geometry ideas. We're going to really hit hard when we're together. So, all right. What do you notice about angles 1 and 3? All right, I notice that they're next to each other. That's a fancy word called adjacent. They share a side. But I also notice that they're on this flat line together. So I know that angle 1 plus angle 3 has to equal 180 degrees. Now, officially, that's because they are a linear pair, and linear pairs are supplementary. So the way I'm going to write that in my reason, and if you don't know this reason, please don't panic. This is not you have to know everything about proofs right now. This is just an intro. And we'll go through a lot of these definitions with a lot more depth as we move forward. Linear pairs mean that they're a pair on a line together. Linear pair, so 1 and 3 are a linear pair. Because they are a linear pair, they have to add to 180, and that's what supplementary means. Now, you might also notice that angle 2 and angle 3 are on a line together as well. So they're also going to equal 180. So now here is a place where people would have a choice, and depending on what book you're looking at or what person you're talking to, they might do it as a separate third step and say 2 plus 3 is 180 by linear pair supplementary. They might get sassy and toss it on to the same line because it has the same reasoning. Okay, you don't get good at proofs by being afraid of them. The best way to get good at proofs is by practicing them. And I don't expect anyone to be a proof professional at the beginning. So if we start this and you watch this video and it makes you panic a little bit, that's okay. Don't worry about it. We're going to keep working on it. And I'm not going to judge you harshly, especially as we start. All right, now, this is a property coming up that I talked about in class on Thursday. And once again, why do I know this? How do I know that this is the way to do this proof? because I am a lot older than a high school student and I have been doing proofs longer than most of you have been alive, and therefore I have the practice at it. It's not because I'm a genius. It's not because I'm better at proofs than other people. There are plenty of proofs out there in the world that I'm sure I could not do, but it's because I've seen proofs like this a billion times at this point practically, and so I have a lot of practice, and that's how I got good at this. It has nothing to do with me being actually like a math genius. I just have seen it a lot. So like when I look at this, in my brain I think, oh, I've seen this pattern before, and that's what it is. It's recognizing the pattern. I notice that 1 plus 3 is equal to 180, and I notice that 2 plus 3 is equal to 180, so I realize that both of these things are equal to 180. We have a property that says if something is equal to the same thing as another, I'm allowed to cut out that middle piece and stick with just this information here. So because they both equal 180, I know that they have to be equal to each other. All right, now if you don't remember the property for that, that's okay. It's called the transitive property. Transitive property always lets us cut out the middle piece and go straight from first to last. And then this last piece is usually the piece that students pick up the fastest because it's algebraic. Notice that each side of my equation has a 3 on it, and it's adding on both sides. How do I get rid of adding to make that matching 3 go away? I'm going to subtract the measure of angle 3 on each side, and then I'm left with the measure of angle 1 equals the measure of angle 2. That's exactly where I was trying to get. If I had written that there were 4 steps out, you could have written that in at the end, even if you didn't know how to get there. How did I get from here to here? I subtracted. Okay, so like I said, we're going to do a whole lot more review on this in live class together. This is not me now expecting you to be a professional proof person or do a whole bunch of proof homework or ace a test on proofs. This is just an intro video so that you can do some work on Tuesday and Wednesday this week, so that when we get together on Thursday and really start doing stuff together, you have some practice, some pre-practice, okay? I hope you have a lovely rest of your day. I hope you had a really good weekend. If you are watching this, like you should be on Tuesday, and I will hopefully see you in class on Thursday. Have a great day, and I'll see you later.